In this video, we are going to learn about law of sines. Now, this law has something to do with the sine value in a triangle. Before we jump onto this lesson, I want us to recap about all the 6 trigonometric functions in a right triangle. So let's move on to that. Okay, so let's focus on all the 6 trigonometric functions in a right triangle. Now here we have a right triangle ABC, which is right angled at B, and the angle here, angle C, is some angle theta. Now the side opposite to the angle theta is this opposite side AB, and the side adjacent to the angle theta is here, this side BC, and this side AC is the hypotenuse. Now we are going to write all the 6 trigonometric functions in this right triangle. Okay, so let's write all the 6 trigonometric functions for this right triangle ABC. Now, to start with it, we should remember this rule, which is SOHCAHTOA. Now, sine theta here is opposite over hypotenuse, which is opposite here, if you can see, is AB over hypotenuse, which is AC. In the same way, cos theta, if you can see, is adjacent over hypotenuse. Adjacent here is BC over hypotenuse here is AC. Now, in the same way, tan theta is opposite over adjacent. Opposite over adjacent, so opposite here is AB over adjacent, which is BC. Now, when we are done with the first 3 trigonometric functions, sine theta, cos theta, and tan theta, we can write the next 3 trigonometric functions, which are actually the inverse of each one of them respectively. So sine theta and cosine theta are inverse functions. So cosine theta is basically flipped reciprocal of opposite hypotenuse, which is hypotenuse over opposite. Now hypotenuse is AC over opposite is AB. In the same way, sec theta is hypotenuse over adjacent, which is here. It's a flipped fraction of cos theta, inverse function. So it will be AC over BC. In the same way, cotangent theta or cot theta will be BC over AB. And we are done. Now let's do a question based on what we just recapped above. So the question here says, find all the 6 trigonometric functions for angle A. Now you can see this is a right triangle ABC, which is a right angled at B, and the angle C is 30 degrees, BC is 8 units, AB is 15 units, AC we don't know, and angle A we don't know. Now let's first find the angle A based on the given information. So if we want to find angle A, we can just apply the right angle sum theorem, or we can apply the angle sum theorem of any triangle. So it will be basically 180 degrees minus angle B, which is 90 degrees, minus angle C, which is 30 degrees. And when you calculate that, it will be 180 degrees minus 120 degrees, which is 60 degrees. So now we find out how much angle A will be. So angle A here is going to be 60 degrees. Now let's find the length of the side AC. So if we want to find the length of the side AC, we need to use the Pythagorean theorem. theorem. Now, according to the Pythagorean theorem, in this right triangle ABC, right angled at B, AB square plus BC square will be equal to AC square. Now, let's substitute the values. AB is 15, so 15 square plus BC, which is 8 square, will be equal to AC square. Now, when you do 15 square, that would be equal to 225, and 8 square will be 64, and that is going to be equal to AC square. Now, when you add 225 and 64, you get 289, which is equal to AC square. Now, once you reach here, you would want to find the value of AC, which is going to be square root of 289. And from here, we get two values of square root of 289, which is plus minus 17. Now we'll ignore the negative value because length is a positive quantity, and thus we get AC equals 17. So now we find AC, which is equal to 17. We'll be able to find out all the 6 trigonometric functions related to angle A, or with respect to angle A. Now, to keep ourselves away from any kind of mistake or any kind of doubt, we first shall write the lengths with respect to angle A. So with respect to angle A, the length opposite angle A is BC, which is 8 units. Length adjacent to angle A is AB, which is 15 units, and the hypotenuse is AC. Hypotenuse is AC, which is 17 units. We just figured it out. Now we can write all the 6 trigonometric functions related to angle A. So sine of angle A is going to be opposite over hypotenuse. Let's first write the famous rule, which comes on really handy for us. It's SOH CA TOA. Now let's use them where we have these very important things, and we shall use them properly. So here we go. Let's do sine of angle A. Sine of angle A is opposite over hypotenuse, which is opposite is BC here over hypotenuse is AC, and that's going to be 8 over 15. Similarly, cos of angle A is going to be adjacent over hypotenuse. Adjacent is AB, hypotenuse is AC, and that is going to be 15 over 17. Now finally, tan of A is going to be opposite over adjacent. Opposite is BC and adjacent is AB, and that is going to be 8 over 15. Once we are done with that, we can write the inverse functions of these 3 basic trigonometric functions. Now that is going to be the inverse of sine of angle A is going to be cosec cosine of angle A, which is Just give me a moment. I'm writing a different one here. Let me use the right hand. Okay, so opposite of sine A is going to be cosec A, which is just reciprocal or inverse function. So we'll write AC over BC, and that is going to be 15 over 8. Opposite of cos is sec. Secant A. Sec A is going to be AC over AB, which is 17 over 15. And in the same way, the inverse function of tan A is cot A, cotangent A, which is going to be AB over BC, and that's going to be 15 over 8. And we are done. Now you must be wondering what law of sines actually is. So we first want to realize that all the triangles which we know are not right-angled triangle, and the 6 trigonometric functions which we just did in this lesson were related to the right-angled triangle. Now look at this triangle. This triangle ABC is definitely not a right-angled triangle. It's a normal triangle where A, B, and C are the angles, and small a, small b, and small c are the length of the sides. So AB is C, small c, BC is A, and AC is B. Now, law of sines is a law which states that the ratio of the angle of a triangle to the length of its opposite side is always equal. So here, angle A, and the opposite side to it is BC, and that is equal to A. That ratio is same as the ratio of angle B to its opposite side AC, and angle C to its opposite side AB. So before we make any conclusion, let's write all of this. So according to the law of sines, it says that the ratio of the angle, the sine of the angle actually, so sine of angle A to its opposite side, which is BC, is equal to the sine of angle B to its opposite side, which is AC, and that is equal to the sine of angle C to its opposite side, which is AB. Now, if you replace BC by its length, the length of the BC is A, and the length of AC is B. Similarly, the length of AB is C. So this is called the law of sines. Now you can figure out one more thing from this relation right here, is that you can actually flip each of these fractions and write them as their reciprocals. So the converse relationship is also true. So you can also write A over sine of A is equal to B over sine of B is equal to C over sine of C. That's the law of sines. Now look at this question here. This is a triangle given to us, and we have been asked to solve triangle ABC. Now have a look. We should look out for the informations which are given in this triangle and what we have to find. So the information which is given is the side AB length is 3 units, that's given, and the angle B is 45 degrees and the angle C is 80 degrees. So three things are given to us. AB is 3 units, angle B is 45 degrees, and angle C is 80 degrees. Now, we have to solve the triangle ABC, means we have to find all the rest of the three things which we need to find. So angle A we need to find, AC we need to find, and BC we need to find. So how we can find all the rest of these three things? First, we can find the measure of the angle A. So measure of angle A we can find by the angle sum property of a triangle. That is, the sum of all interior angles in a triangle sum up to 180 degrees. So angle A is going to be 180 degree minus 80 degree minus 45 degrees. So that is going to be equal to 180 minus 125 degrees. So that's going to be 55 degrees if I'm not wrong. Yeah. So once we find the angle measure of angle A, now we can find the length of the sides AB, AC and BC using the law of sines. So here, as you can see, I have labeled side BC and side AC. You must be wondering how I have labeled them. So you can see angle A, the opposite of angle A is the side BC, so I have labeled it small a, and the opposite of angle B is side AC, so I have labeled it B, small b. So now let's establish the law of sines here, which says that sine of angle A over small a is going to be sine of angle B over small b, and that is going to be sine of angle C over C. Now let's substitute the values here, and then we'll be able to find out a lot of things. So let's start. Sine of angle A. Well, angle A is something which we don't know about. What about A? Yes, we don't know about A as well. What is sine of B? Well, we know that angle B is 45 degrees, so we'll write 45 degrees here. B is what we don't know. Sine of C. Sine of C. Now, you can see angle C is 80 degrees, so we'll write 80 degrees over C, which is AB, and AB length is 3 units. So now we'll start replacing and making equations here. Now you can see we have these three fractions which are equated among each other. Now you can see fraction 3, let's label them. This is fraction 1, this is fraction 2, and this is fraction 3. So you can see that in fraction 1 and in fraction 2, we have the variables which we need to know, A and B. But in fraction 3, we have everything, sine of 80 degrees and 3 units. So let's just establish an equation. So what we can do, we can establish an equation between first and third. So we can write, I'm going to write here, so we can write sine of angle A over A is equal to sine of 80 degrees over 3. And in the same way, I can write now a relation between fraction second, sine of 45 degrees over B, equals sine of 80 degree over 3. So what I've done basically is I have made a relation, established an equation between fraction first and fraction third, and the same way fraction second and fraction third. Now we can start solving them, and it's pretty easy. We can just do cross multiplication here and cross multiplication there. Let's solve the first one. So we can write 3 times sine of A equals A times sine of 80. Now you can see A is the variable which we need to find. So what we'll do is we would want to isolate alone the variable A. So what we'll do is we'll divide both sides by sine of 80 degrees and sine of 80 degrees here. And then our problem will be a bit easier. I would encourage you to stop the video and try to find the solution of this problem. Now, as you can see that we can cancel out sine 80 over sine 80, and now we are remained with 3 times sine of 50 degrees over sine of 80 degrees, that is going to be equal to A. So when you solve it using a calculator, a scientific calculator, you can find that the value of A will be somewhere around 2.5. Now what is A here? A is the length of the side BC, and that's how we find length of side BC, which is equal to 2.5. I would encourage you to stop the video and solve the second equation between the fraction second and fraction third here. I hope you took your time and solved the second fraction here, and when you'll equate them and put the values in by doing cross multiplication, you'll find that the value of B here is 2.2 using the scientific calculator. And you know now that B is nothing but the length of the side AC. So AC is equal to 2.2. Now let's look at a real life situation here where we use law of sines in real life. So as you can see it in the picture, well, this is a picture of craters on the planet Mars. Craters are very big, huge, a hole, kind of hole in the ground, which are really big. They can be bigger than any city on planet Earth. And the distances between them, there are 3 craters here. One crater, this one is Wahoo, one is Wabash, and this one here is Nokon. Now these are the 3 craters, and the distance between them is made along to look like a triangle, and the angles between them is also measured here. This angle here is 102 degrees, this angle here is 23 degrees, and the distance between these 2 craters, Wahoo and Wabash, is 1.2 kilometers. Now we have been asked to find the distance between Wahoo and Nokon, this crater and this crater. Now I've tried to recreate the same triangle here and give them some labels. So you can see I have labeled Wahoo as A, Wabash as B, and Nokon as C. The length AB here is 1.2 kilometers. The length between Wabash and Nokon is BC, which is not known. The length between Wahoo and Nokon is not known. And this angle B is 102 degrees, and the angle C here is 23 degrees. Now what we want to find here is the distance between Wahoo and Nokon. So we will be using the law of sines. We will be using the law of sines to find out the distance between Wahoo and Nokon. Now first thing first, you need to identify the distance between Wahoo and Nokon here is nothing else but AC. So basically we need to find the length AC here. Now let's establish the relation here between the angles and their opposite sides. So Let's start. Sine of angle A over its opposite side, which is BC, is going to be equal to sine of angle B over its opposite side, which is AC. That is going to be equal to sine of angle C and its opposite side, which is AB. Now, as you can see, we have been given a few things, and there are a few things which we have not been given. So let's try to replace those values here. So sine of A, angle A is not given to us. So, well, let's try to first find out the sine of angle A if we want to. So let's find the angle A. Angle A here is going to be 180 degrees minus 102 degrees minus 23 degrees. And 180 degrees, now this combined together are 125 degrees. Now what is 180 minus 125? So basically, if you do 130 plus 50, that is 180, and you have to add in 5 more, so that's equal to 55 degrees. So basically we've got angle A, which is equal to 55 degrees. So sine of angle A, which is 55 degrees, over BC, which we don't know, is equal to sine of B, sine of 102 degrees, over AC, which we want to find out. That is equal to sine of C, which is 23 degrees, over AB. And AB is 1.2 kilometers. Now, as you can see, we need to find the measure of AC here. And since we need to find the measure of AC here, well, it's pretty much simple that we just need to make an equation here using these two fractions. So let's make an equation here using these two fractions, and that will be sine of 102 degrees over AC is equal to sine of 23 degrees over 1.2. Now we know the basics to go on from here, so I encourage you to stop the video or pause the video and go on solving for it. Once you're done solving with that, you'll get to know that AC is approximately equal to 3, and that means the distance between the craters Wahoo and Nokan is approximately equal to 3 kilometers. And we're done. The trigonometric value of sine can also be used to find the area of a triangle. Have a look at this triangle ABC. Now this ABC is a normal triangle, it's not a right angle triangle, but you can see that the length AB, BC and AC are given there. AB length is small c, BC length is small a, and AC length is small b. Now to find the area of this triangle, what we can do is we can drop a perpendicular from the vertex B on the side AC, because we know that the area of a triangle is given by half of base of the triangle times the height. Now this is times, this is not x, this is times. Okay, so now we want to find, if we know the value of the base b, And if we know the value of the height h of this triangle ABC, we can easily find the area of this triangle. Now as you can see that the base of this triangle ABC is AC, and the length of AC is B. The height of this triangle is, let's give it a value, which is, let's say that this is D. So the height BD is H. Now, so we have this couple of things and we need to find the area of this triangle. Now let's say that the angles in this triangle are known to us. This is angle A, this is angle A here, this is angle C, and this is angle B. Now when we dropped a perpendicular on the base AC here, this here triangle ABD becomes a right angled triangle. So in a right angled triangle, this is a right angled sign, ADB, we can find the sine of angle A. The sine of angle A is, we can use the SOHCAHTOA. So it's opposite over hypotenuse. Now opposite of angle A, you can see the opposite of angle A is H. And what is the hypotenuse? Hypotenuse is C. Now from here we can easily find out the value of H. The value of H is sine A times C. Now we are going to use the formula of finding the area of a triangle. Area of triangle ABC here is half times base of the triangle times the height. Now you can see half here times base times H. If you can see here, H is sine A times C. Now when you write them all together, you're going to find it out as half of sine A times C here. So you're going to find it out here that it's going to be half BC times sine A. Now this is a very important formula to find the triangle area, the area of triangle ABC, using two sides, length of two sides, and sine of one angle. Now you can see very clearly that they are not just two sides. Here, angle B and angle C, the length B and the length C have angle A as its included angle. Angle A is the included angle between side AB and side AC. So in the same way, you can actually write area of triangle ABC in terms of other sides as well. So you can write area of triangle ABC if you want to write, let's say side A times side B, then you are going to multiply it with this sine of angle C, and this is going to be the side of angle C. In the same way, we can also write the area of the triangle ABC if you are going to choose the side A and C, then you are going to multiply it with the sine of angle B, and this is how we find the formula to write the area of a triangle ABC when the length of two sides and the included angle is given to us. Let's do now one example to understand this question. Now we have been asked to find the area of triangle ABC here, where the side length AC is given to us, 9 centimeter. The side length BC is given to us, and you can see the included side between these two triangles, these two sides, is also given to us, 104 degrees. Now using the formula to find the area of this triangle, we can easily find out the area. So we can just write area of triangle ABC is going to be half of the side AC times the side BC times the sine of angle 104 degrees, because 104 degrees angle C is actually the included angle, and that's what we have learned a few minutes ago. So this is going to be AC is basically, if you can say, it's 9 centimeters. BC is 8 centimeters. And we have to find the sine of 104 degrees that you can find using the scientific calculator. And when you solve it, you are going to get approx 36 square centimeters. That's an approx value. You can write the accurate value using the calculator. And we are done with the lesson. This is the use of law of sines and how we can use law of sines in real life, and how we can find the area of a triangle using law of sines. That's all for today in this video.